Okay, so what we're seeing here is clearly not BlueJ. I am opened up in Photoshop. This is the same image that we had before. If I resize this image size, and currently 640 by 480, let's say I make this 64 by 48 pixels, and it shrinks down. It's so tiny. And then if I go image size, bring it back to 640 by 480, it is still going to suffer the kind of degradation that we saw before. So let me undo those changes, because at least Photoshop uses memory to maintain a history. The main thing I want to talk about is not so much the destructive nature of image size, but instead to look at the channels palette and also at the histogram. So if I look at the window for info, as I move my cursor around, you can see that each pixel has a value between 0 and 255 for red, green, and blue. This is a 24-bit image, so we have 24 bits, 8 bits per byte. We have 3 bytes of color data, 1 byte for the red, 1 byte for the green, 1 byte for the blue. That means that we can have very, very low values, or if it's pure black, it's 0, 0, 0. If we get up to pure white, or close to pure white, it would be 255, 255, 255. And the combinations between give us the different colors. So here in the sky, we have all blue, surprisingly a little bit of, quite a bit of red, a little bit of green to get that color. We're here at Westminster, and we have that kind of brownish color. It's 102 in the red, 95 in the green, 85 in the blue. So each one of these individual pixels has 3 different color components. Now, over here in the channel, we're looking at all R, G, and B. It is possible to just look at how much red is in the image. So if I look at just the red channel, you might have expected this to turn red, but that's not what this is doing. What this is doing is it is showing us on each pixel what is the value of the red component. So it takes the green component and the blue component and it makes it equivalent. So you see right here, this pixel has a value of 101 in red, so it makes it a color of gray by making the green and blue the exact same value. Places that appear white have more red component. Places that appear black have less red component. If I go to the green channel, notice the image shifts slightly. But now what it's doing is it's reading the green value and making all of the components the same as the green value. And then the blue channel, it's just showing us how much blue there is in an image. Let me change to a different image from London. So if I choose open, and let's go to, well, let's try the BlueJ icon. How much red is there in the image? There's a lot of red in that blue. Well, maybe not a lot of red because it's gray. And there's a lot of red in the white because white is made up of all red, all green, all blue. There's no red inside of the black. With the green, there's a bit of green in that blue. And with the blue, the gray gets even lighter. The blue channel, because this blue must have a lot of blue component in it to help get that color. In fact, if I look at the info window, this blue has a value of 178. If I go to the blue component, 178. So we can see that that's moving over. One of the filters I'm asking you to write, or actually 3 of the filters I'm asking you to write, are these channel filters. Show the red channel data, show the green channel data, show the blue channel data. And hopefully that helps give you some ideas about how to approach that particular